Hello, my friends. I'm Clover, and this is the gas puzzle from July 26th, 2024. I apologize for the delayed solve video. This puzzle came out the morning after I spent a Friday evening having emergency dental surgery, and I obviously did not get a chance to make a walkthrough at that point, and it slipped my mind to pick it back up, but I'm catching up on some videos now, so I thought I would go ahead and take care of this as a little bonus video for you guys if you want to revisit this puzzle. So, this is XVX by Philip Newman. So this actually predates our August variant guessing game. So this was not one of the variants that solvers were supposed to guess in advance. This is just Philip having fun with the fact that Sudoku X and also XV pairs Sudoku kind of play nicely together. So Sudoku rules apply, so we're placing digits 1 through 9 once each in each row, each column, and each 3x3 outlined region. Then we also have diagonal, aka Sudoku X. What that means is that the digits 1 through 9 also appear once each on each of the marked blue diagonals. And then finally we have XV pairs. That means that digits that are separated by a V sum to 5 and digits that are separated by an X sum to 10. It's the pairs variant, meaning that not all of the clues that could be given have necessarily been given, so there could be other pairs that have those sums that haven't been marked with an X or a V. All we know is that the ones that have been marked, they do have that relationship. They sum to 5 or they sum to 10. So let's solve. So there are only two ways to make a sum of 5 in standard Sudoku. We can do 1 and 4 or 2 and 3, and because we already have a 4 in this row, this will have to be the 2-3 option. And that forces this to be the 1-4 option in this order. These have to be 2 and 3, and these now have to be 1 and 4, because the only remaining digit in that row that hadn't been used already that could possibly be part of a 5 sum was 4. Now, this V sum can't be 1 plus 4, because then we couldn't put anything in this cell, so this has to be 2 plus 3 in some order. And exact same thing is going on right here. These can't be 2 plus 3 because we couldn't put anything in this cell, so these have to be 1 plus 4, and same thing here, that is a 4 and a 1. Okay, next thing that stands out to me is we have 4 10 clues, and there's this funny thing about Sudoku, all of the digits 1 through 9 in any row, column, or region sum to 45. So each of these 10 clues sums to 10. 10 times 4 is 40, so we have 5 left over. That means the digit in the middle is going to be a 5. Okay, so now, if you look at this 1 and 4 here, there are only two positions where we can put 1 and 4 in this region. They'll go here and here. One of them will get paired with a 6, and the other will get paired with a 9 to sum to 10. So now I'm going to turn my attention to this diagonal, because it's almost complete. I have 1, I have 2 and 3, I have 4, and I have 6 and 9. So the only things I still need are 7 and 8. And sure enough, there is a 7 here in this column that lets me place an 8, and then I can place the 7 down here, so I have every one of my 1 through 9 on that diagonal. 8 sums with 2 to make 10, so that resolves. And 7 sums with 3 to make 10, so that resolves. Okay, perfect. Now, we have this 2 that we just placed that resolves this 3 and 2, and the 3 we just placed resolves this 2 and 3. These X clues are now easy to get because we have to use to sum to 10 one low digit, 1, 2, 3, or 4, and one high digit, 6, 7, 8, or 9. Okay, we've already used 3 of our 4 possible low digits in this region, so the only one we have left is 1. So this has to be 1 plus 9 to make 10. But if we look at this diagonal, the diagonal is going to save the day again because we already have a 1. So we have to use the 9 on the diagonal and the 1 over here. Similar logic down here, we've already used 1, 2, and 3. We only have one low digit left. It's got to be 4, so this is 4 plus 6. We already have a 4 on the diagonal, so that'll be a 6, and that will be a 4. Okay, so where do we go next? It's a little bit less clear from here, but let's find something else to work on in this puzzle. We need to place a 2 in this region. It has to go in one of those cells. We need 5, 6, 7, and 9 here. That's not quite enough to... I think the most restricted thing right now is actually this negative diagonal. So we still need a 7 and an 8 on the diagonal to finish it off. Everything else is taken care of, so they'll go in these positions. And because there's a 7 here, once again, we can place them. 7 pairs with 3 to sum to 10, and 8 pairs with 2, and that will actually place that 2 that we were wondering about a minute ago. These 3's see almost all of the cells in region 8, so 3 is going to end up going here as well. These will be 5, 6, 8, and 9. Okay, I have 2 8's here. I'm going to place an 8 here. I need 5, 7, and 9 to finish this region. I need 5, 8, and 9 here. And I need a 7 right there. In this region, I need 5, 6, 7, and 9. That can't be a 9. That can't be a 7. That can't be a 6. Can't really do much with that yet. Flailing just a little bit here. Maybe I should look at the central regions. Okay, so 7's here see these cells, and this 7 sees this cell, so that's going to be a 7. And I have, what do I have over here? These will be 1, 4, and 9. And that makes this a naked 9. Perfect. And this can't be a 7, so I have a 5, 9 pair here. This is now a 1, 4 pair, and to finish off this region, I need a 3, a 5, and a 6. These can't be 3 because of the 3 there, so my 3 will go right here. This 5, 6 pair gives me a 9 and a 1 and resolves these, and also resolves this. These cells will contain 8 and 9. These cells will contain 2 and 4. These will be 6 and 8. These will be 5, 6, and 7. Okay. I need an 8 or a 9 here, and a 5, 8, or 9 there, which cannot be an 8. 9 is already accounted for in this column. That reduces this to a 5, 6, 8 triple, and these will be 7 and 9, and we know the order because of the 7 in row 7. The 5 I just placed makes this a 9. And also, this now reduces to an 8 and a 6. And I think we're pretty much just doing classic Sudoku at this juncture. In this column, I'm going to need a 6 and an 8. Here I need a 5, 7, and 9. The 5, 7 pair there gives me a 6, and that should finish everything off. And that is how you solve Philip Newman's XVX from July 26th, 2024. If you enjoyed that, if you want to solve it yourself, there's a link in the description below this video. Check it out. It's already been solved quite a few times, as you can see by the solution counter there. Just because I'm coming to this one a little bit late, it's already close to 3,000 people got to it before I did, but if you struggled with this one, I hope that this video helped you out, and I will catch you next time. Thanks for watching.